Every atom in your body is 13 billion years old, and it will outlive you forever. Every atom in your body is 13 billion years old, and not one of them will ever die. Today, we follow your atoms after you're gone.
Buckle up. This gets weird.
Not a sad story. A cosmic one that goes further than you'd ever guess. Chapter 1, The Last Hour. The moment your heart stops, nothing actually disappears. Every single atom that ever made you stays exactly where it is. Your body simply stops directing them.
Think of it like an orchestra going silent. The instruments don't vanish, they just stop playing together.
Within hours, your cells run out of oxygen and stop working. Within days, tiny organisms begin the great unbuilding. Bacteria that lived peacefully inside you your whole life get to work. They break your complex molecules back down into simple pieces. Proteins become amino acids. Fats become simple carbon chains. Within months, even your bones begin to soften and release their minerals. Carbon, nitrogen, calcium, water. The exact same raw ingredients as everything else on Earth. You were never really separate from the world around you. Chapter 2, The Forges of Creation. Here's the wild part. You didn't actually make those atoms. Not one of them. You borrowed every single one.
So where did they actually come from?
It started right at the beginning of everything. The Big Bang. In the first 3 minutes, the universe made just two elements, hydrogen and helium. That's basically it. Every hydrogen atom in your body right now is that old. Older than the sun, older than Earth. Older than almost anything. But hydrogen and helium alone can't make a human being. For the heavier stuff, the universe needed furnaces, stars. Deep in every star's core, immense pressure fuses atoms together. Hydrogen fuses into helium. Helium fuses into carbon. Carbon into oxygen. Every breath of oxygen you've ever taken was born inside a star like that.
That's basically the coolest thing I've ever heard.
But a normal star can only build elements up to iron. Fusing iron costs more energy than it releases. So the furnace stalls. A giant star ran out of fuel billions of years ago. Its core collapsed in less than a second. Then it exploded with the brightness of a billion suns. A supernova. For a few violent seconds, that explosion forged elements heavier than iron. Calcium for your bones. Iron for your blood. Iodine for your thyroid. But some elements are so heavy, not even a supernova is violent enough. For gold, platinum, uranium. You need something even more extreme. Two dead neutron stars, spiraling into each other and colliding. Astronomers actually watched this happen in 2017, for the very first time. They call it a kilonova. It forges gold by the mountain load. So that ring on someone's finger? Forged in a stellar car crash. Every explosion flung its new atoms outward, across the whole galaxy.
So somewhere out there, my atoms just went flying?
For billions of years, they drifted through empty space as dust, until gravity gathered a cloud of that dust together. That cloud became our sun. And our Earth. And eventually, after billions more years, some of that dust became you. You are a star, and a supernova, and a neutron star collision, that learned to ask questions. Chapter 3, One Atom's Journey. Let's make this real. Let's follow just one atom. Right now, in your lungs, call it an oxygen atom. Let's trace where it's actually been. 8 billion years ago, it was forged inside a dying star. That star exploded, and flung it into a drifting cloud of dust. 4.5 billion years ago, it became part of our forming Earth. For hundreds of millions of years, it was locked inside solid rock. A volcano finally released it, as part of a cloud of steam. It fell as rain, and became part of Earth's very first ocean. For a while, it drifted through that ocean, doing nothing much at all. Then early bacteria pulled it in, and used it to breathe. 200 million years ago, it was inhaled by a stegosaurus. It cycled through plants, oceans, and clouds for another 100 million years. 2,000 years ago, it might have been in a cup of water in Rome. Maybe even in a breath taken by someone building the pyramids. It evaporated again. Fell as snow during an ice age. It has been part of a cloud over every continent on Earth. And right now, this exact second, it's part of a breath in your lungs.
Whoa. That's not just a story, that's basically IT's memoir.
In a few seconds, you'll breathe it back out. And its journey continues. That is the actual, literal history of one atom inside you right now. But not every atom's journey looks the same. Let's follow a second one. This time, a carbon atom. Also forged inside a dying star, long ago. But this one had very different luck. It got trapped, deep underground, crushed under immense heat and pressure, for over a billion years. Slowly, atom by atom, it became part of a diamond. It sat there, doing absolutely nothing, while continents drifted above it. Eventually, a volcanic eruption blasted it violently back up to the surface. A person dug it up, cut it, and polished it into a gem. For all we know, it's sitting in a ring somewhere right now. One atom spent its whole story breathing. The other spent it frozen solid.
Same origin. Wildly different lives. That's kind of beautiful.
Every single atom out there has its own version of this story. How do we actually know any of this? Nobody's watched an atom for billions of years. It's not a guess. It's some genuinely clever scientific detective work. Every element glows with its own unique fingerprint of light. Split a star's light through a prism, and you can read exactly what it's made of. That's called spectroscopy. It works from millions of light years away. In the 1950s, scientists studied exactly how elements form inside stars. A famous paper, nicknamed B²FH, laid the whole theory out. It explained, step by step, how stars build every element on the periodic table. Since then, we've confirmed it again and again, with real observations. We've literally watched supernovae explode, and measured the new elements they create. In 2017, we watched 2 neutron stars collide, and detected fresh gold forming. This isn't ancient mythology. It's some of the best tested physics we have. Chapter 4, The Great Recycling. So back to you. After you die, where do your atoms actually go? Nowhere, really. They just change jobs.
Picture it like a game of cosmic musical chairs that never, ever stops.
Some atoms sink into the soil, and become part of the earth itself. Plant roots often pull them back up within just weeks. They become part of a leaf. Or an apple. Or a blade of grass. Some atoms evaporate into the air, as ordinary water vapor. They fall somewhere else entirely as rain. Maybe on another continent. Here's a fact that sounds impossible, but is actually just simple math. One single breath contains about 10 sextillion molecules of air. Earth's whole atmosphere holds about 100 million times more than that. Air fully mixes around the entire planet in just a couple of years. Which means, statistically, you've already breathed atoms once breathed by dinosaurs. And atoms once breathed by absolutely every person who has ever lived.
Wait, so I'm breathing ancient history right now?
Julius Caesar. Cleopatra. Your own great-great-grandparents. All of them. Nothing is ever thrown away. It's all still circulating, right now. Your atoms will do this. Forever, essentially. Soil. Plant. Animal. Ocean. Cloud. Rain. Soil again. It's the only kind of immortality that's actually, scientifically real. Quick real-world question. Does it matter how you're recycled? Actually, yes. It changes the speed, not the outcome. Buried in soil, your atoms release slowly, over 10 to 20 years. Cremated, and most of your carbon becomes gas in under 2 hours. It rises as carbon dioxide, and a tree nearby could be breathing it in by next week. Buried at sea, and ocean currents could carry your atoms around the whole planet. Different roads. Same destination. You end up back in the great recycling either way. Chapter 5, What You're Really Made Of. Let's actually break down what's in you. Element by element. About 65% of your body is oxygen. Almost 2/3 of you is the exact same stuff that makes water. Next up, carbon. About 18% of you. Carbon is the backbone of literally every molecule in your body. It's forged deep inside stars through something called the triple alpha process. Then hydrogen. About 10%. The oldest atoms inside you, born in the first 3 minutes after the Big Bang itself. Nitrogen makes up about 3%. It forms your DNA and your proteins. Then calcium. Around 1.5%. Forged inside supernovae. Every bone and tooth in your body is quite literally supernova debris. Phosphorus. Potassium. Sulfur. Sodium. Chlorine. Magnesium. Tiny amounts, but every one of them essential. And every one of them stellar. And then there's iron. Less than 1/10%, but it's the exact reason your blood is red, and can carry oxygen at all. Iron is forged in the final, violent seconds of a dying star's core. So right now, a piece of a star's death is beating inside your chest.
Every single heartbeat is a tiny echo of an exploding star.
You're not mostly made of Earth. You're mostly made of dead stars. Chapter 6, Atoms That Outlasted Empires. Let's zoom out now. Way, way out. Ancient Egypt rose and fell. Your atoms were already here. The last mammoths died out. Your atoms didn't even notice. The Roman Empire rose and fell. Still here. The printing press. The world wars. The moon landing. All just background noise.
That's kind of terrifying and kind of amazing, honestly.
Atoms simply don't experience time the way we do. A human life lasts about 80 years, if you're lucky. Some of your atoms are older than the dinosaurs by billions of years. Some are older than Earth itself. You are, quite literally, walking around in atoms older than the ground beneath you. And after you're gone, they'll outlast every building we've ever built. Every language that's ever been spoken. Every civilization that hasn't even been built yet. Your atoms have nowhere to be. They have all the time in the universe. To really feel that scale, if Earth's whole history were one single year, dinosaurs wouldn't even show up until the middle of December. All of recorded human history would fit inside the final 10 seconds. Your atoms have been part of nearly the entire year. Not just the last 10 seconds. Chapter 7, Everything Must End. Even the Earth itself. Let's jump forward now. 5 billion years from now, our sun will finally run out of hydrogen fuel in its core. It will swell up into a monster called a red giant. It will grow so big, it swallows Mercury completely whole. Then Venus, boiled away entirely, without a trace left behind. Then, almost certainly, Earth.
Wait, what? Earth gets eaten by the sun?
Every mountain. Every ocean. Every single thing you've ever seen, vaporized in an instant. Even the moon won't survive it, torn apart by the sun's swelling tides. Mars might survive, but as a scorched, airless husk of rock. Jupiter's icy moons might briefly, strangely, melt and grow warm oceans. A short, strange window for life, right as everything else ends. Your atoms, still cycling through soil and air and rain, will scatter too. Blown outward on a massive wave of solar wind. Out past where Mars used to calmly orbit. Out past the icy edge of what used to be our solar system. Eventually, our sun will shrink down into a small, dense white dwarf. It will just sit there, slowly cooling, for trillions of years. But your atoms won't be there to see it. They'll already be free. What about the rest of the solar system, once the sun calms back down? Jupiter and Saturn survive, but as cold, dark husks with no sunlight to speak of. Saturn's beautiful rings will likely be long gone by then anyway. Uranus and Neptune drift on almost completely undisturbed, frozen and distant. The asteroid belt, and the Kuiper belt beyond it, mostly just drift on unchanged. So our solar system doesn't vanish. It just becomes a quiet, cold, empty version of itself. Chapter 8, Back to the Stars. So what actually happens to a free-floating atom out in deep space? Honestly, it depends. There are a few very different possible fates.
Bloop, give me the options.
Option 1, it just drifts, alone, for the rest of time. Most atoms in the universe are doing exactly this, right now. Option 2, it drifts into a nebula. A stellar nursery. Gravity slowly pulls the gas and dust together over millions of years. It could become part of a brand new star, being born. Or it could become part of a brand new planet instead. Maybe even a planet with oceans. And mountains. And weather. Maybe, one day, a planet with life of its own.
You mean MY atoms could end up alive again?
Not you. Not your memories. Just your atoms, doing it all over again. Maybe even in a creature that looks up at its own night sky and wonders exactly where its atoms came from. Option 3, it gets pulled toward the center of the galaxy. Eventually, over unthinkable timescales, even swallowed by a black hole. Option 4, it gets flung entirely out of the galaxy, drifting alone, forever, in the vast empty space between galaxies. Every single atom is currently living out one of these stories. Chapter 9, The Very, Very Far Future. Let's push this all the way. How does the universe itself end? 100 trillion years from now, every single star has burned out. No new stars can form anymore. There's simply no gas left to make them. Galaxies drift so far apart, they can no longer even see each other. Eventually, all that's left are cold, dead stars, and black holes. Even black holes don't last forever, as strange as that sounds. Stephen Hawking showed they leak a tiny trickle of energy, and slowly shrink. Given enough time, unimaginable amounts of time, even they evaporate completely. We're talking about a number with over 100 zeros in it. Some physicists even think individual protons might eventually decay. If that's true, even your atoms wouldn't last completely forever. But we're talking about a timescale so long, it's basically theoretical. Nobody has ever actually observed a proton decay. It's still just a theory. What's left, at the very end, is called the heat death of the universe. A cold, dark, silent void, where particles are separated by unimaginable distances. No stars. No light. No motion, really. Just stillness, forever. It's a genuinely strange place to end a story about your atoms.
Okay, that got a lot bigger than I expected.
To be fair, that's just the leading theory. It's called the Big Freeze. There are other, wilder ideas about how it could all end. The Big Rip, dark energy tears galaxies, then stars, then atoms themselves apart. The Big Crunch, gravity eventually wins, and the whole universe collapses back inward. Right now, our best measurements favor the slow, cold Big Freeze, but honestly? Nobody knows for absolutely certain. Not yet, anyway. Here's one truly wild idea some physicists genuinely debate, just for fun. In an infinite amount of time, could random particles ever, briefly, reassemble into a mind? They call the idea a Boltzmann brain. It's pure speculation, but it's wild to think about. Either way, it would take longer than any number we can meaningfully picture. Okay, but be honest. This has all been about atoms. What about actually, me?
That's the real question underneath all of this, isn't it?
Your memories, your thoughts, your personality, live in the specific pattern of your brain, not in any single atom. The atoms in your brain already get swapped constantly, while you're alive. Most of the atoms in your body today aren't the same ones you had 10 years ago. You've been a slightly different set of atoms your entire life. And you're still you. So it's honestly the pattern, the arrangement, that makes you you. Not the specific atoms. When you die, that exact pattern doesn't continue. That part is real, and it's okay to feel that. But the raw material, the atoms that pattern was built from, absolutely does continue. And they'll go on to become part of new patterns. New moments. New Wonder. Chapter 10, The Cosmic Answer. So, after all of that, what really happens after you die? You don't disappear. You transform. Every atom keeps existing. Keeps moving. Keeps working, somewhere, in soil. In oceans. In the next living thing that breathes. And maybe, billions of years from now, inside a brand new star. Long, long before the universe ever reaches that cold, silent ending. You are not a temporary thing, just borrowing space in the universe. You are the universe. Arranged, for a little while, into you. And when that arrangement ends, nothing about you is truly lost. It just becomes the next beautiful thing, somewhere out there. Right now, in this exact moment, you get to be the one wondering about it. That's a pretty incredible thing to get to do, even just once. So the next time you look up at the stars, remember, you're not just looking at them.
You're related to them.
Next time, we're exploring what's actually inside a black hole. Subscribe, and come find out with Zorp and Bloop.
See you on the next trip. Smash that subscribe button, human. See you next trip.